So every year, all around the world, there are reported UFO sightings. So people see these like unidentified objects and they decide, I need to let someone know about it. That information is gathered together into a massive CSV file, and we're going to look at a small subset of that data that started in 2013 all the way to the end of the following year. It should come as no surprise to you that the most reported UFO sightings took place in the United States of America, at a whopping 8,021 reported sightings. And I thought to myself, with such a cool data set at my disposal, this would be a perfect way to dive deeper into the world of GraphQL, and I hope that today you feel the same. We're going to start by looking at the basics. What is it that you absolutely need to know in order to work with GraphQL? And we're going to do that by covering 3 different things that GraphQL is and GraphQL is not. So first, GraphQL is a query language for your API. And if you've started to look at GraphQL at all, you've probably heard someone say that before. But what is a query language in the first place? Here's an example of a very well-known query language, which is... Okay, great. So you're developers, right? Structured query language. It's actually in the name. It's made up of keywords like select and from, and these determine the what and where of how the data is going to be received. So in this case with SQL, we're going to send a request to a database, and then we'll get back a subset of records. Now when it comes to GraphQL, this is what a query looks like in GraphQL. It too contains keywords. So here's one, query, or the operation type. This is letting you know that you want to get some information back. It could also be a mutation, that you want to change some data, or a subscription, that you're interested in finding out changes. The next part is the operation name. This is really useful for debugging, or if you're doing some sort of server-side logging. And then finally, inside of those first set of curly braces, this is where you define the object or objects that you're actually interested in. So this is the what of what you want. And then inside that inner set of curly braces is the how. These are the fields. So I want to know about UFO sightings, but I only care about the IDs of the sightings and then their shapes. So unlike SQL though, this query is going to go to our API. And once it's there, we'll receive a response back as JSON. So if we take a closer look at this, the first thing to notice is that it's just regular JSON that we've been working with since forever. And inside of that is a data property. And then we get a list of our UFO sighting records. If you want to wrap your head around, okay, GraphQL versus REST, this is the best way that I find that it sticks with me, is a query in GraphQL is very similar to a GET request in the REST world. And a mutation is basically every single thing else. So post, put, delete, etc. And if you know anything about mutations, it can take something really simple like cute little turtles, and it can turn them into super teenage mutant ninja turtles. And if you would like to know more about this, please see me after the talk, if you don't know about the turtles. They're heroes in a half shell. Anyway, so that's the key thing. Keep in mind, mutations, you're changing something versus the query, you're getting some data back. Okay, second thing about GraphQL. GraphQL is a specification. This is really important because it means that it's language agnostic. It was developed by Facebook, and you can actually read the entire spec ad nauseum if you're interested. It tells you everything about the fields, the operations, the types, every single thing you want to know about GraphQL is contained here in this spec. So for us, on the server side, this means you can write GraphQL Server in any language you want. There's a lot available like C# and Kotlin, Java, Ruby, etc. And the same thing applies for the client side. So it's kind of interesting, this list grows all the time. So every time I check back again, it seems like there's another language that has implemented a GraphQL server or client. And finally, GraphQL is introspective. So you'll hear that a lot, introspective. This means that a GraphQL type system should be able to be queried by GraphQL itself. So it's kind of like GraphQL can just take a step back and really look at itself and understand what's going on. This is important because it allows you to do really powerful tooling. So here's an example of an introspective query. We're using this type meta field to get information about something in my schema, a UFO sighting. But what am I interested in? I want to know the names of all the fields inside of that object. So if I were to run this query against my GraphQL server, then I would get back some JSON, just right back there again, inside of a data, and it will have a list of the names of every single field that's in my object in the schema. So this is really cool, and this is one of the things that you'll always hear people say about GraphQL, is that it has really, really powerful tooling, and that's because it's introspective. So far, we've talked about how it's just a query language. It can make requests, get back responses. It's a specification. This means it's language agnostic. And finally, it's introspective. And this is what powers a lot of the tooling around GraphQL. But so what? Okay, now you know these things. Why would you want to use GraphQL? But first, we have to talk a little bit about REST. Why is REST so painful for people? Well, let's say I wanted to get a list of UFO sightings. With a REST endpoint, I can make my requests, and then I'd get back all this data. But if I was actually only interested in, let's say, the ID and the shape for each sighting, well, I pulled back all this extra data that I didn't need and I wasn't interested in. Also, if I wanted to have not only the sighting record, but the user who reported it, then I'd have to make multiple requests or bundle tons of things. And then finally, REST is historically known for having bad documentation. Maybe you could use something like Swagger to have better documentation, but then that often gets out of date. So let's look at how GraphQL aims to kind of fix these issues. First, you only get what you ask for. So in this example, I would like a UFO sighting with this ID and this information, and that's all I get back. So it's not whoa, but it's nice. This is all I care about, so that's all I get back. Also, you can have nested queries together. So let's say I wanted to get 2 UFO sightings, and then I also need a list of the top country sightings. I can do those things in just one request. So there's no need in making multiple requests or doing many round trips if I know exactly the data that I need on the client side. And finally, documentation is just built right in. So this is a screenshot from GraphQL. You'll kind of hear that tool used a lot around GraphQL. And all of these things are basically just links that you can dive deeper and deeper into the documentation. And as someone who works with the GraphQL API on the client side, it's really nice not to have to ask the backend developers, okay, well, what about this? What is this field's type? How can I get more information? You can just look at it yourself. Okay, so we talked about a little bit about the basics, and now we'll look at a server implementation of GraphQL, and we'll start like any GraphQL server, what does it need to do? So the first thing is that there's a single endpoint /GraphQL, and this is pretty standard. There can be some variations, but this is it. You can make a GET request to that endpoint where your query is just a string. So in this example, I'm just making a GET request, and I want to get a list of UFO sightings with these fields. I could also make a POST request, same thing, except this time I'm sending in some JSON. And this is something that it may be more common to you if you've started working with GraphQL a little bit so far. And what's nice about this is that you can now use your existing HTTP products. So how many people here have used Postman before? Okay, the rest of you. Yeah, so Postman is amazing for helping you debug what's going on with your API. And we just took that same query, slapped it in Postman, and then we're getting our results. So right here, we can still see there's the JSON with the data, and then the list of UFO sightings whenever the GIF scrolls, okay? So right there, we're still using existing tools. Then here's a slightly more complicated version where I'm passing in some variables. So I'm saying, hey, okay, I'm gonna make the size of the number of sightings variable. I'll get back the same results as before, but this just shows you how you don't have to like learn something totally new in order to start working with GraphQL. Okay, so let's look at building our server. And basically Kotlin, that's what I did. So I said, I want to build a server and I want to use all Kotlin. So what did I do? I used Ktor for the server framework. I used Coin for dependency injection, Squash for the database library, and then KGraphQL, which is like the real star of the show, for the GraphQL server. And that's what we'll be focusing on the most. Now, any GraphQL server is made up of types, the schema, and then resolvers. So we'll look at these one by one, and we'll start with the types. This is just you saying, okay, this is what I want to give to the world. And in my case, I wanted to give UFO sightings to the world. And those UFO sightings would contain these scalar fields. So the int with the exclamation mark means that, okay, this thing can't be nullable, whereas the string, it can be nullable. Okay, and for scalar types, there's no more like digging deep. So you can't say, okay, I want to get some more information out of an ID. Nope, that's not how it works. Once something is a scalar in your schema, that's it. So there's no more digging deep. And how would you define this in KGraphQL? That's it. So it's really simple. It just uses this type you pass in your data class, and it knows, okay, based on the fields that you specified. So in Kotlin, it's kind of the opposite. So the int without the question mark means it can't be nullable, whereas the string with the question mark, it will be interpreted as being able to be nullable. So these two things are exactly equivalent. So one of them is in the GraphQL schema, and the other one is how you would represent it using KGraphQL. Okay, so that's the schema. Now, our schema is really simple for this example, but you can imagine, as I showed you earlier, you can have mutations and you can have subscriptions and other things, but we only have query. And then from there, we define the type of the query. And in this case, it's just one example, a sighting. So we're going to pass in an ID, and we're going to get back a UFO sighting. And just like you saw before, we're going to define what a UFO sighting means in our schema. So with GraphQL, it's all about building up what's included in your schema, and then trying to specify that in whatever language it is that you choose. What's really nice about using this notation is that anyone in any type of language can understand what your schema is made up of. And that's not distracting me at all. So with the schema, it's really important. This is your contract with the client. So this is the client saying, hey, this is what I'm interested in. And you're like, okay, this is what I can give you. And this is the type of the various fields. So that's why the schema is really key. Now, in Kotlin, if you wanted to represent that same schema using KGraphQL, you would start with this outer wrapper of a schema, our type once again, and then you use this query function where you pass in the name of the query that you want. Now, something new, there's a resolver. And you notice that it takes in a lambda with an ID. So let's talk a bit more about resolvers and the role that they play in our GraphQL server. Okay. So this, you can think of a resolver as the map between GraphQL world and then your application domain. So in this case, let's say I want to get a UFO sighting and I have it stored in my database. Then I can just make a call to my database and get back the record. But I could also not even have a database. I could just make an HTTP request, same thing, get back some UFO sighting, and then pass it on. So in my opinion, this is one of the really cool things about GraphQL is that it doesn't matter where your data is. The client has no idea. They just know if I'm going to give you this ID, then I'm going to get back this UFO sighting record according to the contract or the schema that was specified. Okay, so if we look at an example, how does the server know, okay, where to get data from and how to process it? So it starts out with the root query, and it'll say, oh, okay, I know, I do have something called sighting that takes an ID. And then it goes and looks like, well, what is it that you want from this UFO sighting record? Okay, you want an ID and you want a shape. I know how to give you those things. Those are scalar. So we're done. Next, oh, okay, now you're asking for an object. Well, I need to find a resolver for that. And once I do, I can give you back the scalar pieces of that as well. Let's go back one. So this is how it kind of traverses your schema to give you this tree-like structure. So GraphQL produces trees. So it's nature friendly. Okay, now one more example. This time we're going to look at a mutation. And we're going to create a new UFO sighting record. Very similar to the last time, but I just want to make it clear that the resolver is doing all the heavy work. So we're just taking something in one world and mapping it to another, and the user has no idea. They just know this is what I'm giving you. Okay, and then finally, using KTOR, we have our /GraphQL endpoint, and there's a little bits and pieces in between, but the main thing is it's taking our query, taking any variables that we send in, and then we're just executing the schema. And just like that, we'll get back our JSON. So it's a really cool library. I really enjoyed learning more about it and getting to create my own GraphQL server. And I do have a link to this repo on GitHub so you can play around with it yourself. Now, what I want to point out about the GraphQL server is basically it's just there. It's just waiting for you to say, here's my request. This is what I want to do based on the schema and the resolvers, all under this one endpoint. So that's everything you need to know about GraphQL servers forever. Moving on to the client. I'm an Android developer, so I made an Android app. And it just displays these UFO sightings. I'm also not a designer, so it looks like this. But it works, it reads the data and it creates new sightings. So it's written in Kotlin, it uses architecture components, and then also Apollo Android for the clients. So let's see how we can take all these pieces together to create our Android application. So first, the Apollo client. This is how you can create one, and it should look pretty familiar to you. Have you ever used Retrofit before? Okay, good. A decent amount of people, probably all the Android developers. And you can specify similar things like the server URL and the OK HTTP client that you want to work with. And that's all you need to set up your Apollo client. And then once you do that, you need to download the schema. So we talked about this before. The schema is the contract between the server and the client. So there can be no contract if the client doesn't know about it. And there are some command line tools that you can use to download the schema. Since this talk, they have added a new one, but I don't believe Apollo Android has caught up yet. So you would still have to use Apollo CodeGen to download the schema, and it just stores it as a JSON file. So GraphQL loves JSON, JSON everywhere. And if you take a little peek inside of it, it's just a super long, nesty JSON file, but it has every single thing that a client would be interested in knowing about your schema. Okay, and then you would create some .graphql files. So this is something just kind of made up by the Apollo team, but this is where you would put your queries. So here's an example. I have a query. I'm going to specify how many records I want back, and then these are the fields that I'm interested in. And so how does it work? Well, the plugin, you create your GraphQL file. The plugin takes it, shakes it up a bit, and creates a bunch of Java files. Not Kotlin, sorry. So it creates all these nested Java files, and it looks like this structure. So it maps to the operation name that you provided for your query, and inside of it are classes for sending your request as well as parsing it. Okay, and the generated code, if we kind of take a peek in here, it has a builder class for the variables, and it scrolls and scrolls. It's a pretty long file, and we only had 3 fields. So yeah, just keep that in mind, but then it also handles parsing the response. Okay, so those 3 things, boom, put them together, we've got an Android app. Now, in order to actually show the data, we need to build the query. So using the generated code that I just showed you, I would say I want 30 UFO sightings or 500, whatever I want, and I could create it. Then I would enqueue the request. So just very, very similar to working with Retrofit. You have a callback and then 2 methods that you would need to override. And then finally, you will handle the response. So keep in mind, we keep saying this like JSON object with data, and then inside of it is the actual thing you're interested in. And so instead of you having to do that, like unwrapping yourself, if you use the plugin, you could just get it this way. So you just say data, and then, yeah, the sightings, and do what you will. And that's how I was able to create the sample Android app for this, and I encourage you to look at the source code, which is available on GitHub as well. So I didn't want to leave you without a few tips and tricks. So as I drink water, you have to be in suspense for what those are. Okay, first, use the IntelliJ GraphQL plugin. It is really, really helpful. It gives you this really nice syntax highlighting that you've been enjoying the entire talk. So it's really easy to see which things are the operation types, which things are like fields. It has code completion. Let's say I decided to type ship instead of shape. It would tell me, look, ship is not in your schema, and it would allow me an opportunity to correct it. So I definitely recommend this, and there is an option available for Android Studio as well. Next, retrofit GraphQL. It's like the new kid on the block, where you can keep using retrofit, but using annotations, you can actually work with GraphQL. So I'm really interested in checking this out. It doesn't have like all the caching support that's available in Apollo Android, but if you're not using it, then you don't need it. And then also, a client is optional. So in some cases, especially with Apollo Android, it would just generate tons of Java objects for some of my queries that I ended up then converting to Kotlin objects. So it was like a waste, and I wasn't doing anything special, so I just didn't need to use it. Keep that in mind. Also, there are public GraphQL APIs available if you just want to start playing around with GraphQL based on someone else's work. Feel free to use these. These are publicly available. And then also, I wanted to share this schema cheat sheet. So if you could start to get confused about like the exclamation marks or the little brackets, what do these different things mean, you can use this cheat sheet, especially when you're first learning, to get up to speed. Okay, so now for some true-false rapid-fire questions to see if you were paying attention this whole time. So GraphQL was designed only for databases. Okay, good. You don't have to use a database at all. It can be anything you want. It doesn't matter. It's up to you to choose what you want to do with your GraphQL server. GraphQL is language agnostic. Okay, very good. So we already saw that there's things available for the server and C#, Elixir, Kotlin, etc., and the same thing applies for the clients. Apollo Android is the only GraphQL client. Right, I just told you about the new kid on the block, right? Or you don't have to use a client at all, so it's totally up to you. It's really flexible, and that's another thing that I appreciate about GraphQL. And finally, REST is dead. Okay, fair enough. So you decide. I personally don't feel that REST is dead, and a lot of the things that you can do with GraphQL, you can also do with a little bit of manipulation using REST APIs, but I do find it very compelling, and I personally have seen a lot of benefit with my company moving towards GraphQL over the 3 different REST APIs that we had before. And as someone who works mostly on client applications, it's really empowering. Even I've been able to just jump in on their Ruby code and add a new field and resolver that I needed with little to no effort whatsoever. So I think that's really cool about GraphQL. Thank you for coming. Hopefully you learned a bit more about GraphQL and you feel empowered to at least start trying it out. I do have links to all the resources and everything I discussed today available on my website, and I will be sending out a tweet that has a link to everything as well. Yeah, so that's it, unless you have questions. No questions, great. All right. I think I have a microphone somewhere. Do I? Okay.
can we somehow update the schema during runtime so that, for example, microservices changed and we don't want to redeploy the GraphQL service? Is it possible?
In your client application?
No, on the server side. So we have like a gateway service, GraphQL, and yeah, we want to change the schema, but we don't want to redeploy it.
You can absolutely change your schema at any time. The dangerous part is that the clients are relying on a previously downloaded schema. So I have run into a situation where some people on the server team like changed something from like a string to an int, and then all of a sudden you start seeing failures in your client app. So like I don't recommend that. You should have a whole process in place for making schema changes to your app.
But is it possible, yeah? So that we can just say, hey, this is a new schema, just run it. Yeah?
Yeah.
Okay, cool. Thanks.
Yeah. Wait, over here, did you have a question?
Yeah, it was more like...
All of you want to do things dynamically. Okay, are you two friends?
No. Okay, so my question is regarding the, can we replace JSON with protocol buffers or something else?
Maybe if you write your own converter for the JSON that comes out of the server, and then have your client prepared to consume it.
Mm-hmm. Okay.
Why not? Yeah, it's just JSON, if that's what you...
No, but I was referring directly, like we make a query server? And that it's natively supported, like not that I have to first convert JSON into another binary protocol or something.
I haven't seen anything that supports anything other than JSON.
Okay.
But you could like do a plugin piece if you wanted to.
Thanks.
Yeah. Over here? I think there's only one mic.
Thanks. I was going to ask, do you have any suggestions regarding errors and like how you'd handle? Would you still handle errors using like HTTP codes? And like, is there any best practices with regards to what happens if there's an error on the back end, for example? How would you deal with like a 500 response or any kind of like 400s?
So if it's a 500 error, it's going to show up in the other callback method in the clients, like the on failure case. But if there's actual like errors, for example, like you did something invalid in the mutation that you sent, that's actually inside of the data. So let's say there was an error where I wanted to get back my UFO sightings. It'd say like data, and then the sightings might be empty, and then underneath that it would say like error. And then you'd have to parse that error yourself inside the app, so it would actually show up as a successful response. So it's more like the failure case should be extremely rare, but errors should be like known things that you can recover from and handle inside of a successful callback.
Cool, thanks. And would that mean that you'd have to specify like the shape of errors within the schema as well, or is like that something that's freeform? You'd have to parse on the client.
Errors string array.
Okay.
Yeah.
Right.
So it would be in there.
That makes sense. Thank you very much.
Yeah, you're welcome. Yes, right here. Oh, wait. I don't know, but this guy has the mic. Okay.
Thanks. Can you hear me?
We'll come back to you.
Yes?
All right.
Okay. Yeah, so my team noticed that the KGraphQL is still in an ODOT. It hasn't reached a 1.0 yet. Have you had any issues with it showing that it's not really production ready yet?
Yeah, I wouldn't use it in production, but to like show some UFO sighting data, it's perfect for that. The GraphQL implementation that my company uses is actually a Ruby gem, which is like very stable, and that's the one we use in production. So yeah, please, okay, maybe I should say like, asterisk disclaimer, don't use KGraphQL in production yet. I haven't run into any issues with it, but I just personally wouldn't do it. But that's a great question, thank you. And do you have it? Okay, good. That's the most questions ever. All right, yes.
So are you opening up this GraphQL API as a public API, or is it close to your application, right? Or is it meant to be used by third parties as well?
You mean this UFO sighting?
No, in general. No, because what
anyone can read it.
Yeah, I'm very interested in UFO sightings. Actually. No, but what I'm worried about is opening up sort of a general query API to third parties who can. I can easily imagine creating a query that would be essentially denial of service attack because you're joining and especially if there's a relational database behind it.
Yeah, so what you would do is still take advantage of HTTP safeguards. So you would use like an authentication token as a header that you would send along with all your requests. So like, yeah, you shouldn't just let anyone do anything to your APIs. And I think that's another reason why I wanted to show you Postman is that it's really clear that it's just something on top of HTTP. So the same normal safeguards that you would have for any other API, you could use for your GraphQL APIs.
Do you know of any query analyzer you could run on the server side to sort of analyze the query before actually running it?
Yeah, so Apollo, they have a lot of analyzers. Yeah, it's like really top tier. I'll say KGraphQL is just like the basic thing that you would need to do in order to say you have a server, a GraphQL server in Kotlin. Yeah. Anyone else? This side of the room? Bueller? Anyone else? Okay. Here in the yellow shirt, he had a question.
Sorry, one more question. I did not understand it correctly that it also generated the documentation HTML file like Swagger does? With like all the possible
the documentation?
queries. Yeah.
Yeah, so it will generate that documentation based on the schema.
Cool, thanks.
Yeah, it's really nice. All right, thank you.